So this video is on the Equilibria, which is the second part of the Unit 4 area, and as always I'm going to start with the basics. So when we refer to equilibrium, it's either to the left, to the right, or dynamic. To the left simply means that the equilibrium favours the reverse reaction, and to the right means it favours the forwards reaction. Dynamic equilibrium is where the rates of the forwards and backwards reactions are exactly equal. So you can kind of just think of this as the 50-50 Holsworth spread. It's the best of both worlds. So for a dynamic equilibrium, the process must be in a closed system and at a constant temperature. The reason it's in a closed system is because then no products can come in or out, or reactants for that matter, which then means that the equilibrium will not be changed by anything that can alter Le Chatelier's principle. So we need to know where the equilibrium lies, and we can find this by using the equilibrium constant Kc. The formula for this is Kc equals the concentration of the products, all divided by the concentration of the reactants. The balancing numbers from the chemical equation will be raised as powers in the Kc equation, and an example is in the manufacture of ammonia, where we have nitrogen, which is 1 mole, plus 3 moles of hydrogen to form 2 moles of ammonia. The Kc expression is the ammonia raised to the power of 2, because it's obviously products over reactants. So this is all divided by 1 nitrogen, so nitrogen to the power of 1, times by hydrogen to the power of 3. So you can see that the balancing numbers have transferred to powers. So once we have our Kc expression, we can get a value for Kc, and this tells us exactly where the equilibrium lies. So when Kc is less than 1, the equilibrium favours the reverse reaction. When Kc is equal to 1, it's a dynamic equilibrium, and when Kc is greater than 1, it favours the forwards reaction. Finally then, the value for Kc is only affected by temperature. And so we might be asked, well, if we increase the temperature, what happens to Kc? Well, if the forwards reaction is exothermic, then Kc will decrease. And I can kind of demonstrate this here. So if we imagine we've got Kc equals concentration of products all divided by concentration of reactants. If we increase the temperature in an exothermic reaction, Le Chatelier's principle says that the equilibrium will shift to the side which is endothermic. So obviously this will be the left side, which is the reactants. So that will increase the concentration of the reactants. So the increase in that will therefore decrease our Kc value, because these are inversely proportional, which is denoted by that sign, but you probably won't ever need to use that, because that's more of a physics term. Similarly then, if we have an endothermic reaction for the forward reaction, Kc will increase, and then this is using the exact same principle as before, whereas this time I will do it in blue. So we'll have our Kc equals products over reactants. So obviously the endothermic side will be the product side this time, so that's what will increase, and these are directly proportional, and you can always think of it as being Kc over 1 if you're going to make it a fraction. These two are both on the top of the fraction, so they're directly proportional. So as products increases, Kc will also increase. And that's all you need to know for the basics of Kc. In my next video I'll just go through a calculation for Kc, just so you can kind of understand how it works, because sometimes they can be a bit confusing.